Good morning, Doctor. I am Mkw4004 from Group 2. Our group members are Mkw4004, Chansinyi, Umaira, and Nur Alia. Our contents for today's presentation is Chapter 1, Modeling and Dynamics of Asset Prices, Chapter 2, Real Application of Monte Carlo Simulation in Finance, and references. Chapter 1, Modeling and Dynamics of Asset Prices. Basic financial asset. We are going to discuss about three fundamental securities, which are bonds, stocks, and derivatives. A stock, which are also known as equity, is a security that represents the ownership certificates of a company. There are two types of stocks, which are common stocks and preferred stocks. Common stocks holder has voting rights that can be exercised. On the contrary, preferred stocks holder does not have voting rights. Bonds are a debt security that are usually issued by companies or government who act as an issuer to fund their activities. The investor who buys bonds will receive an amount of money corresponding to the par value of the bond at maturity. The example of bonds including coupon bond and zero coupon bond. Derivatives are financial instruments in which the payoff depends on the underlying instrument. The most common elementary derivative products that traded on exchanges are future contracts and options. Fixed income securities are a type of debt instrument that provides returns in the form of regular or fixed interest payments and repayments of the principal when the security reaches maturity. Various types of formulas shown below are used to calculate rate of return, simple and compound interest, and discrete and continuously compounded present value.
Selamat sejahtera kepada Doktor. I am Singi and now I will continue to the third part from the Chapter 1, which is the subtopic of the modeling and dynamic of the asset prices. In the modeling and dynamics of asset prices, one is able to predict the randomness of the asset prices, and it is very useful for people in financial decision making. So now I will continue to showing on how the modeling and dynamics of the asset prices work. So first, the part from the discrete to continuous time, which means that how we obtain the continuous time model from a discrete time model. So I have summarized in three steps, where the first step is to take the natural logarithm of the stock price, and second, we will let the S0 as the initial price of the stock, and then we unfolding the equation shown. So we find that the stock price is normally distributed. We will also obtain the expected value and variance by using the notation shown. After that, we integrate the equation in order to get the continuous time model as our third step. Next, I will proceed with the standard winner process. In standard winner process, we consider the following process as a building block. There are four properties of the standard winner process, which first, the W0 is equal to W0, second, the increments are independent, stationary, and also the increments are normally distributed. And by assuming that the stochastic process ST is satisfying the equation, we will have the equation shown. So where the A is represents the drift rate and the B is represents the variance of rate. Next, I will proceed with the Idos Lemma. Idos process is actually similar and can be said that it is apart from the generalized winner process, which is the equation of dxt equals to adt plus bdwt, which shown in the previous slide. The only difference is that the generalized Wiener process used the constant of a and b, while the Idos Lemma used the function of axt and the bxt. And this are shown the Idos Lemma equation. And since the generalized Wiener process is not really independent, and since it assumes that the rate of return depends on the stock price, but in fact the rate of return should be independent and therefore not depends on the ST, which means the stock price. So in order to solve this problem, a geometric Brownian motion is introduced, and this is the equation of the geometric Brownian motion. In this slide, an example regarding to the geometric Brownian motion is given, and the stochastic differential equation of the geometric Brownian motion is given as dst equals to the mu st dt plus sigma st dwt. And we are asked to find the stochastic differential equation for st, which is the log st, and then we are asked to leave the answer in the explanation form. And in order to find the stochastic differential equation for fst, we need to apply the Idos Lemma. So we first compute the partial derivatives. So after we compute the partial derivatives, we substitute back the partial derivatives into the Idos Lemma equation. And after we get the stochastic differential equation, we integrate the equation that we obtain, and we will get the answer in the explanation form. For example 2, it is also an example regarding to the geometric Brownian motion. It's just that in this equation, we are asked to plot a path of the stock price from time t0 equals to 0 to time t equals to 2, with the initial stock price of S0 equal to the 30, and with the step delta t is equal to 1/400. And we are asked to solve this question by using the MATLAB, and this is the coding that we use to solve the example given.
Hi and Assalamualaikum warahmatullahi wabarakatuh. I'm Nur Alia binti Abdul Razak, S60127. For part B, we need to study and analyze chapter 2 topic numerical integration, deterministic and Monte Carlo regarding a journal article which has a real application of Monte Carlo simulation in finance or economics. So for our group, we choose a general application of Monte Carlo simulation method in risk management. This article is about value at risk that has become one of the most important tools in the science of risk management. As an information, VAR is a metric that quantifies the extent of potential financial losses within a company, portfolio or position over a given time period. This value at risk has become one of the most significant instruments in the science of risk management over the last 20 years because of the capabilities itself. It can be used to calculate a precise quantitative measure of risk on the downside. Currently, there are tens of various techniques to value at risk computation in the scientific world. As we go through the journal, we have 2 of problem statements and 2 objectives. The first problem statement is how value at risk can provide a precise quantitative measure of downside risk. Then, how to select one approach that will provide a reasonably accurate estimate of risk at a reasonable cost using MATLAB software. For the objective, firstly, we want to identify which is the possible approaches to value at risk calculation would provide a reasonably accurate estimate at risk at reasonable cost. The second objective is we want to find the accuracy of value at risk by using MATLAB.
Hi, Doctor and friends. My name Umairah binti Shamsuri with matrix number S59572. Before I explain about the result our group acquired, I will briefly explain about the method that used based in the journal. As stated in the journal, there are 2 major categories in approaching to value at risk, which are the local valuation methods and full valuation methods. Local valuation methods are generally represented by delta normal approach, and it measures the risk by valuing the portfolio at the initial position on D, while the full valuation methods are generally represented by historical simulation approach and Monte Carlo simulation approach, and it measures the risk by valuing the portfolio over a range of scenarios. In this journal, the approach of Monte Carlo simulation is chosen instead of the historical simulation. Besides, another important opinion said that the history of the actual price is limited source of possible outcome to find value at risk. Hence, Monte Carlo simulation is chosen to answer both of these arguments. Monte Carlo simulation is actually the most complicated of three mathematical approaches mentioned above, and thus a special software which is MATLAB version 7.0 is chosen in order to quantify value at risk in an efficient way. In order to show how the Monte Carlo method works in MATLAB, the forex portfolio of the biggest Latvian banks, which consists of 44 different world currencies, is used as our example. On the slide shows the programming code of our algorithm. There exist two parts in the first line of the programming code, where the first part before the equal symbol is the function name and the second part of the after equal symbol shows the variable used in the function. There are a few of built-in functions used in the algorithm. The last line of the algorithm uses function plot to draw a graph, and the expression in the function dvp and b star give an instruction to mark all meanings of dvp variable with blue color in the graph. Lastly, the symbol star is used to mark every meaning of the variable. Next, I will explain to you the result that we acquired after run our coding. By testing the algorithm introduced above, the real data is used. The influence of variable t, p, and L, modification on the final result will be analyzed. At first, variable L is modified, but leaving the T and P remain unchanged at 95% and 100% level respectively. The L variable is equated to 100, 1000, 10,000, and 100,000, and 100 runs of the algorithm is made with each L. Table 1 and Figure 1 show on the slides the result of the algorithm. From Table 1, it can be concluded that the number of simulations increases result in the decreasing of the standard deviations. Next, variable t is modified by taking the number of periods from 1 to 10. The result is shown in the Table 2. Lastly, variable p is modified by taking the probabilities of 0.66, 0.85, 0.95, 0.97, and 0.99. The result of the value at risk is shown in the Table 3. Value at risk keep growing its popularity since it has been applied in three important financial areas including risk limitation, proper rating calculations, and capital adequacy calculations with incorporation of correlation between assets. Use of Monte Carlo method actually helps a lot as the model can be used in order to predict the probability of the different outcomes when there is the inversion of random variable is present. Monte Carlo simulations also no doubt help to explain the impact of risk and the uncertainty in prediction of forecasting models. All of these references are used in order for our group to write the report. That's all from us from Group 2. Thank you.